Hello class, this is your video for intermittent IV infusion. I'll post two videos, one for part 1 first dose data and another for steady state infusion data. Excuse me. As I have mentioned, first thing you have to carefully read the question. Here in this case, the question asks you that you are administering drug for short 1 hour infusion. So you have to remember that infusion time is equal to 1 hour, and it is called TINF. It is not T infinity. It is infusion. Okay, and then drug was administered every 8 hours. So this also you have to take into consideration. First one was 900 hour, second dose was 1700, and then at 1. So that means every 8 hours you have 2 doses, first dose, second dose, third dose. So first thing, you draw a diagram like this. This is your first dose, which is your 9 hour, second dose, which is 1700, and then your third dose is. So we are going to calculate all the parameters, kinetic parameter based on first dose. So we will focus on here this first dose. So this should be the intervals 1900 and 1700. It will be your interval. So this is your interval for first dose. So first thing, the question is asking to calculate K. To calculate K, you have to find the T trough and T peak. So let's use the first equation. We're going to use equation. Your equation is going to be K. For this, K is equal to ln C peak by C trough, and then T trough minus T peak. We already know. So another thing, first you have to do, identify which one is peak sample and trough sample. This is trough sample, this is peak sample. So always first thing, you identify time, dosing interval, which is peak sample, which is trough sample. So, and as it is in the first dose, if you look into the time, if the drug was administered, the drug started at 9, okay, and that was infused, let's see, what's going on. So let's put this time here, 1, 2, 3, 4, 1 hour, 0. So when you administer drug for an hour, so you started at 9. You started at 9 administering the drug. You started, for example, 9 am administering drug for an hour. So here you collected peak sample at so 1 hour, and then you collected peak sample here at 10:30. So this is the infusion time, 1 hour, and when you stop, this would be your Cmax, and Cmax is at 10. So, and then you collect a trough sample at 16:30, and your dosing interval ends at 1700. You are going to administer, so you have to calculate this time. So your T trough is equal to 1600 and T peak is equal to 1030. So this way you find out that the difference between 1600 and 1030 is going to be 0.060. So here is easy now. K is equal to L, and peak is 3.78 and trough is 1.35, and time, which is T trough minus T peak would be 1630 minus 1030. So 1630 minus 1030 would be 6 hours. So there, this, if you do the calculation, you will have a K of 0.1716, or which you can write 0.172. So this is how you calculate K. Once you know the calculation of K, then things are going to be a little easier. Let's clear this. Now K is equal to 0.171 hour per hour. So then T half, so easy, 0.693 divided by K is equal to 0.693 divided by 0.1716 is 0.04. So here is your T half. Now maximum concentration after the first dose. So again, to calculate maximum concentration after the first dose, we have to make the graph again. So here infusion was started as 9, and you infused for an hour, 1 hour, and then you stopped at 10. You stop your infusion on hour at 10, and then you collected a sample at 10:30. This is the time for Cmax, and this is your Cp. Our delta T would be this one. Delta T is equal to 10:30 minus 10 is going to be 0.5 hour or 30 minutes. So here now, to calculate Cmax, you have to use this equation. Cmax at first dose. Cmax is equal to Cp divided by e to the negative k delta t. Sorry, delta t is small t. This is your delta t. So to calculate To calculate Cmax, you put Cpeak. You know already what is your Cpeak, which is 3.78 e to the negative. We know our K is 0.1716, and we know that delta T is, we figure delta T is, which is 10, 30 minus 10, which is going to be 0.5. Do not put 30 minutes there, then you will have the wrong answer. Do not put 30 minutes, so just 30 minutes means 0.5 power. You should get a Cmax of 4.118 milligram per liter. We are not playing with unit here, so you don't have to worry much about unit. So this is your Cmax. Now you have to calculate Cmean. To calculate Cmean, again you draw that line. Okay. You know that dosing interval ends at 1700. Dosing interval, we know that here from there, always you look at what time dosing interval ends. End of dosing interval means it should be your Cmean when you are going to start. And then you took the sample, trough sample, because we are going to, we put the trough sample at 1630. So in this case, your delta T is going to be 1700 minus 1630, which is 30 minutes, 0.5 hour. Remember, this delta T is 0.5 hour. Sometime it could be different. So just you have to calculate always, please. And don't assume that, okay, it's going to be always same. You may have different numbers, so you have to always be careful. So to calculate Cmean, we are going to use this equation. Cmean is C trough times e to the negative k delta T. So C trough, you know what is your C trough? C trough, I think is C trough is 1.35 e to the negative 1. Let's do this. E to the negative 0.1716 times 0.5. So this should give you a Cmean of 1.239 milligram per liter. So we have Cmean and Cmax after first dose. Now we have to do some more calculation. This is Cmax at steady state, Cmean at steady state. In this case, we do not have Cmax information about steady state concentration. We don't know anything about CS or what will be the CA, this one. So for this reason, we have to go backward. We have to backtrack on some of the equation. If we have to find out accumulate, you perhaps remember there is an equation for Cmax at steady state is Cmax times Cmax first dose time RSCC. So we don't have RSCC here. We have Cmax. We can use that earlier Cmax we have calculated, which is, let's put our Cmax was 4.118 milligram per liter. Our Our Cmean is 1.239 milligram per liter. So to calculate Cmax steady state, we have to use this equation. We have to go back to multiple dosing. So to calculate Cmax times RSCC. So how we calculate RSCC? RSCC is equal to 1 by 1 E negative K tau. And we already know what is our K. In this case, our K is 0.1716 hour, and tau, if you go back there, it's 8 hour. Tau is 8 hour. So now you put this information here in this data is equal to 1 minus E negative 0.1716 time tau is 8. So your RSCC would be, I think, 1.3394. I'm not showing the calculation. I'm not using calculator because to save time, as I've mentioned before. So you have now RSCC. To calculate RSCC, if you know that RSCC, you set this data here. You know what is your Cmax? Your Cmax is 4.118 times RSCC is 1.3394, and this should give you 5.51 milligram per liter. So this is your Cmax at steady state. To calculate now Cmean at steady state, same thing. Cmean at steady state, what do you do? Cmean is equal to Cmean at steady state, Cmean first dose times RSCC. So we already know Cmean is 1.239 times RSCC is going to be 1.3394 is equal to, this is going to be Cmean is 1.239, 1.3394. Your Cmean is going to be 1.659 milligram per liter. So here you have now, let's clean this again. You have your Cmax at steady state is 5.51 milligram per liter. Cmean at steady state is 1.659 milligram per liter. I wish I had better handwriting, sorry. So you have that Cmax, Cmean at steady state and Cmax at steady state. So just remember, in case of the Cmax at steady state, Cmean steady, you have to go backward. You have to find RSCC, and you have to calculate RSCC. You use that equation for multiple dosing. So this is a equation. RSCC is equal to 1. No, this thing is like this. Now volume distribution. I have mentioned volume distribution. You can just take this dose you can take dose divided by Cmax. It is not going to give you perfect volume distribution. For this reason, we will use a complex equation. So my complex equation for V first dose, you go back to this equation here. Here you go, ladies and gentlemen. Here. Very big. Anyway, this is the equation we are going to use here. V, this is the equation V first. It is going to be the equation R0 divided by K times 1 minus e to the negative K T infusion. Do not get confused with infinities. T infusion is infusion time, duration of infusion, and then Cmax. As I have mentioned in the class, you perhaps remember that we have to use this Cmax to consideration the elimination of the drug. So you know that to use this equation, okay, let's find out what is what. What is your R0? R0 is infusion rate. So dosing rate or infusion rate, it is R0 is equal to, in our case, if you go back, if 100 milligram per hour, if it were 30 minutes, 100 minutes, it would be 200 milligram per hour. So you just have to be careful. So when you are calculating dosing rate, so your dosing rate is 100 milligram per hour, and then you have to calculate infusion. T infusion, you know that it was infused for an hour. T infusion is equal to 1 hour. T infusion is an hour. And then what is the Cmax? We figured that Cmax was your Cmax, if you go back, which was this one, is 4.118 milligram per liter. So what else we need? We have Cmax, and we have to have K. K is equal to 0.1716. We have dosing rate, we have Cmax, we have K infusion. So everything, we have everything now. So you put those information here. R0 100 divided by 11716 times 1 minus e to the negative K, which is 0.1716 times T is 1. T is 1. Time T is 1. This is a parenthesis. And then we have Cmax is 4.118. So you do this calculation, use your calculator or whatever you want, or Excel sheet. I have a fancy one app, so which I use to do this calculation. It is 22.3 liter. And remember, this is the volume distribution, real volume distribution, which took into consideration the elimination during the infusion time. So now you have your volume distribution, you have your K, then how are you going to calculate your clearance? That's easy. That equation we have been using forever, which is, your equation is CL is equal to K times V. K is 0.1716 times So V is 22.31 is going to give you 3.82 liter per hour. That is here is milliliter per minute. Just you have to convert it to, it should be, if you convert it to there is a formula there, what is liter per hour to liter per minute. If you go to Google, it will say that you multiply with this. Here it is going to be 63.81 milliliter per minute. So this is all about first part of the assignment. So I'll summarize what are those things you have to do again. I know that this is going to be a long video, but that is important, that most important thing that you understand. Things we need to do first. First thing we have to read this. Read. This is called reading. Like 100 milligram dose of kinetomycin was administered. So we know this would be tau. This would be T infusion. And this is your dose. And also you identify dosing interval. This would be your peak sample. This would be your trough sample. So first thing you have to identify this trough sample, and then use different equation. For this one, use K is equal to ln C peak C trough divided by T trough minus T peak. Once you know the half-life, and for maximum concentration or Cmax at first dose, always you have to calculate delta T, which is this one. Delta T, you may get confused with delta T. Always remember that what is delta T. Cmax, your Cmax here, your Cmin here, your C peak here, C trough here, C trough. So this is your delta T for Cmin, this is your delta T for Cmax. So, and then you use that equation, Cmax is equal to C peak divided by E negative K delta T, and for Cmin you are going to use this C trough times e to the negative K delta T. This is trough. And then one of the equation you have to always remember, that which is not part of this lecture, it is part of the previous lecture, that you have to calculate steady state, you have to calculate RSCC, and for this RSCC you have to use a different equation. So you have to go back to this equation, 1 minus e to the negative K tau, and then same is, once you know RSCC you can calculate Cmin. And volume of distribution, for volume of distribution you have to know, use this complex equation, V first dose is equal to R0 by K 1 minus e to the negative K T infusion divided by Cmax. Remember, I'll write it again, negative K T infusion. It is not tau, it is not delta T, it is not T trough minus, this is the infusion time, and it is easy to find out from here. It will be 30 minutes, 40 minutes. If it's 30 minutes, you convert it to 0.5. And so once you know these things, these are easy to calculate. This is the video for the first part of the assignment. I will work on it on the second part in a little bit. Thank you.